Hello, and today we're going to learn how to solve trigonometric equations. This is only part one. We're only going to look at simpler cases where there's only one trig function in the equation. Eventually, in other parts, we're going to look at what happens as they get more and more complex, the equation. Alrighty, let's start with a very simple equation. Sine of x is equal to 1. So we're trying to locate the angle where the sine value is 1, meaning the y value is 1. So where is the y value 1 on the unit circle? There's only one place between 0 and 360 that it's 1, and that's up here. Okay. All right. So and that's 90 degrees or pi over 2. Now that's not the only angle that if I take the sine of would give me 1. For example, what if I went 360 degrees or 2 pi, and then went an additional 90 degrees or pi over 2? That angle, which is not equivalent, it is coterminal, would also give me a sine value of 1/2 because the y-coordinate for that is also 1. So we need to be careful. There's actually an infinite number of angles that would give me a y value of 1 because I can go around this thing however many circles I want to and then go up to the having my terminal side at what would normally be 90 degrees. So this is how we qualify those infinite cases. We say that whatever we're taking the sine of, which in this case is just x, is equal to pi over 2. But you can go and add however many circles you want once you reach pi over 2. So a full circle is 2 pi. And you can multiply that by any integer n. So n stands for integers. So if n is 1, 2, 3, 4, 5, that means that you go pi over 2, and then you can go in a circle as many times as you want, 1, 2, 3, 4, 5, 6 times. n could also be negative. You can certainly add pi over 2 and then subtract a full circle. You'd end up right back over there. So this gives you every single possible value, in this case for x, that when you take the sine of that angle would give you 1. Okay? Let's look at another example. Tangent of x minus root 3 is equal to 0. Okay, so in order to solve this, let's try to isolate tangent of x. So tangent of x is equal to the square root of 3. Okay, so where is tangent the square root of 3? That happens right up here. Whoops, right up here. And tangent's also positive in this quadrant right here in the third, so it also happens here. Go away. Happens here. Alright, this is pi over 3 that this happens, and this is 4 pi over 3. So those are the two angles between 0 and 2 pi where our tangent is the square root of 3. Alright, now notice there's actually something interesting about these 2 points, is that they're pi away from each other. If I start here at pi over 3 and I add a pi, I'll end up here. If I add another pi, I'll end up right back here. Different angle, but it's still coterminal with pi over 3. Add another pi, I'll end up here. Again, different angle, but coterminal with 4 pi over 3. What's actually kind of neat about this is if I continually add pi, I will hit all of the infinite values of the angles that, if I take the tangent of it, will get me root 3. So what we can say is, well, whatever we're taking the tangent of, in this case it's x, is equal to, if we travel pi over 3, and then we travel an additional pi, and we can do this however many times we want, we're going to end up at every single possible solution for the tangent of x is equal to root 3. So this is our solution. X is equal to pi over 3 plus pi n. Again, n is an integer, so it's any whole number. It can be 0 if you want to, because if it was 0, it would just be pi over 3, which works. Alright, let's get a little bit more complicated. Cosine squared of 2x is equal to 1. We'd first need to start off by taking the square root of both sides. When you do that, remember when you take the square root of something that has a variable in it, you end up getting an absolute value. The square root of 1 is 1. We can deal with these absolute values by saying, well, that means that either cosine of 2x is positive or negative 1. So we'll write it as cosine of x is equal to positive or negative 1. Alright, let's look at our unit circle. Where is cosine positive or negative 1? Cosine is positive or negative 1 here, where it's positive 1, and here, where it's negative 1. This is 0, and then this is pi, and this is 2 pi, and this is 3 pi, and this is 4 pi, 5 pi. I can also go backwards. 0, negative pi, negative 2 pi, negative 3 pi, negative 4 pi. So it's every multiple of pi, which means whatever we're taking the cosine of, which is 2x, is equal to any multiple of pi. And that would be my cosine is equal to positive or negative 1. Now we're not done yet because we haven't solved for x. We need to divide both sides by 2. So x is equal to pi over 2 n. So if you, again, n is an integer, so any integer you want to think of for n, if you were to substitute in any integer and then figure out what this value is and you substituted it into this equation, you'd end up getting a solution. So this is your solution. All right, let's look at one more before we go. This time, instead of writing in terms of radians, it looks like we're going to use degrees because we're actually given degrees on the inside of the secant. All right. So we're looking for where the secant of something. Again, we'll just call this whole inside some variable. We'll call it theta. So secant of theta is equal to 2. Where's secant equal to 2? Secant's 2 where cosine is a half. Cosine is a half here. Oh, go away. Cosine is a half here at pi over 3. Cosine is also a half, positive 1/2 here at 5 pi over 3. Okay? Now, these are not equidistant from each other. To go from here to here, I would need to travel 4 pi over 3. And to go from here to here, I'd only need to travel 2 pi over 3. So I can't continually go in the same distance and hit all of my answers because they're not equidistant from each other. So we're going to need to set up two different equations. One where whatever we're taking the secant of, in this case it's 2x minus 45 degrees. And actually, let's write these in terms of degrees to keep the consistency. So this is a 60-degree angle, and this is a 300-degree angle. Okay? So that's equal to 60 degrees, plus we can go, once we're here at 60 degrees, we can go in a circle as many times as we want and still end up at a place where the secant is 2, so plus 360 times n. Okay. Also, I'm going to leave a little bit of space here. 2x minus 45 degrees is equal to 300 degrees plus, and again, once we're at 300, we can go in a full circle as many times as we want. We go 300 degrees, then we can go an additional 360, an additional 360, and we'll end up at an angle where the secant will be 2. Okay, so we have not solved for x yet. We've only figured out what the inside of the secant is equal to, so we need to add 45 to both sides. Here that would give me 2x is equal to, you would add 45 to 60, so that's 105 plus 360n. Remember that when you add something to the left side of an equation, you add it to the right side only once. So we added 45 to this one term. We would add 45. I would add it to this term. All right, let's do the same thing down here. So we'd add 45 to both sides. So we get 2x is equal to, add 45 to this would be 345 degrees plus 360 degrees n. We're still not done. We would need to divide both sides by 2. So we get x is equal to, this would be 52.5, get that decimal there, degrees, plus 180 degrees n. When you're dividing, you have to divide everything in the equation by the same value, or every term rather. So we divide this by 2, divide this by 2, divide this by 2. So that is one of our solutions. We do the same thing down here, so we need to divide this side by 2 and everything on this side by 2, so it can be 172.5 degrees plus 180 degrees n, and that is solved for x. So both of these circled values are solutions for x. Again, n is any integer you want it to be, and that would satisfy this equation up here. All right, that's the easiest way to solve for a trig equation. This is when you have one trig function. In part 2, we're going to look at what happens when you have multiple trig functions in the same equation.